Alright, kiddies, so this is Unit 4, Day 1. Okay, we're going to be graphing and writing inequalities. So, the inequality word, basically, it just stands for not equal. Okay, so we're not using the equal sign. We're going to be using these four symbols down here that you can see. We got greater than, or lesser than or equal to, greater than or equal to, less than, and greater than. So, to kick things off, we've got less than or equal to. Okay, or equal to. Alright, now, these are going to be using a darkened in dot. Okay, we're going to make sure that our dots are all nice and darkened in for these. Okay, notice the little line underneath gets the darkened dot. Now, less than or equal to, things that you can expect to see along with that are things in that at most phrases and stuff like that. Now, the other version of this is, of course, the greater than. Greater than or equal to. Okay? And, of course, that's going to be a darkened dot as well. Okay? Notice that we have that little line underneath. Okay? And that means that we're going to shade in our dot for this one. Okay? And this is going to be things like at least. Okay? And y'all can probably think of some other words or phrases to use for these two symbols. Okay? Next, we got less than. Alright? And this is just plain old less than. Alright? Notice no dot, no line underneath. Okay? So it's going to remain open. Alright? And of course down here we got greater than. Okay? Again, notice no line underneath. It's going to remain open. Less than is going to be things like smaller. Okay? Greater than, of course, is going to be things like more than. Or larger than. And I'm sure that y'all can come up with some other words to plug into this. Alright? And as y'all come up with words, and as we get through the notes and you see other words that can be used for these different symbols, we'll come back and we will plug those in. Alright? Now, let's see. So, number 1 here, it's asking, is each number a solution of x is less than or equal to 7? Alright, so is 9 less than or equal to 7? Well, 9 is bigger than 7, so no. Alright, is -1 less than or equal to 7? Yes. -1 is considerably smaller than 7. Alright, and then down here we've got 14 divided by 2, which is, in fact, 7. Alright, now, is 7 less than or equal to 7? So basically, does it fall into this category? Or could it fall into this category? It does fall into that category, so yes, it is a solution. Alright. Now, down here, it's asking us to write an inequality for each graph and determine if each is a solution. So, on number 2, it's asking us to write an inequality for this. So we're going to start off with x. We know we're going to have a -4 because that's where the dot is. So let's see, x is everything that's less than, everything that is to the left of it, everything that is smaller than -4, so less than. And since that's an open dot, we don't have a line underneath it. So it's asking, is -4 a solution? Well, since that's an open dot, -4 is not a solution. Okay? And let's see, number 3. So, it's asking, well, first of all, we got to do the same thing. We got to write an inequality. So we got x, and the dot's at -1. So let's see, x is going to be everything bigger than -1, everything to the right. So x is greater than, okay? And since it's a darkened in dot, we got a line underneath it. So x is greater than or equal to -1. And it's asking, is -2.5 a solution? So -2.5 comes between -2 and -3. Okay, somewhere right in there. So that's -2.5. And as you can see, that doesn't fall in this region right here. It's way off here by itself. So that is a no. Okay? Some of y'all I've said to use your number line. Okay? This is where it's going to kind of come in handy. Make sure that you know where things are and where things fall on the number line. On number 4, we've got x, and the dot's at 5. So, let's see, x is going to be everything smaller than 5. So x is less than 5. And since it's a darkened dot, we're going to draw ourselves a line underneath it. And it's asking, is 0 a solution? Well, 0 is in the darkened in range, so yes. Alright, next we've got, that looks like about, let's see, x, and we're going to call it 1/2. Okay, and x has to be everything bigger than 1/2. Okay, since that's an open dot, we're going to not put a line underneath it. No line underneath. Okay, and is 2 a solution? So is this in the answer set? And that is a yes. Alright? Pretty simple stuff so far. Alright, next we're going to graph. We're actually going to get to graph some of these. Now, the way that I usually graph these is I put the number that I'm dealing with smack dab in the middle. Okay? So I'm just going to put a -2 right here. I'm going to leave an open dot above it. Okay? And it says C is everything bigger than -2. So I'm going to go that way. Alright? Alright, next. Excuse me. Alright, so we got 3/4. And we're going to make sure to put a darkened in dot above that, because we have this line underneath it. And n is everything smaller than 3/4. So it's going to go off to the left, like that. Alright. Number 8. We're going to start this thing at 2. We're going to leave an open dot above it. And 2 is bigger than P is what that's saying. Okay? Another way of saying that is P is smaller than 2. So we're going to go off to the left with this. Like that. Alright, number 9. We're going to start this one at 4. We're going to put a darkened in dot above it. Okay? And M is bigger, so we're going to go off to the right. And there it is. First page of notes done. Alright, so moving right along here. Okay, we're going to start this one at negative 7 halves. So negative 7 over 2 with a darkened dot. Okay, and that's going to be b greater than that. So b is everything bigger than negative 7 halves. It's going to go that way. Alright, and then we're going to have a q. No q. Whoops. We're going to start this next one at 0. So let's see, q is bigger than that. So we're going to go to the right. Number 12 starts at negative 4. Okay. We're going to have a closed dot. And z is smaller. So we're going to go off to the left. Okay. And number 13 is pretty much the exact same thing, only different number, right? We're going to put a 1 below it. Open dot. W is less than that. So everything to the left. And there it is. Alright. So the next thing we're going to be renting a car. So to rent a car, you must be at least 21 years old. So that means at 21 years old, the day that you turn 21, you can rent a car. So what we're going to wind up with is a graph that looks a little something like this. And it's going to be, in our final inequality for this is going to look like this. X needs to be greater than or equal to 21. Alright? So the next one, whoop, totally did not want that on there. Okay. And if you notice, we have this nifty, you must be at least. Okay? So, and I believe that I mentioned that somewhere near the beginning of this whole ordeal. So you might want to make sure that at least is in the greater than or equal to section. Okay? Your parents will let you use at most 2 gigs of data on your cell phone plan. Okay? So, we've got 2. Okay, at most. So that means that we can use 2 gigs. Okay, if we go over, we're going to mess up the plan. And we're going to have to pay a bunch of overages, and they usually take that out on you in some way, shape, or form. So let's stay under 2 gigs, right? That's going to be off in this direction. Okay? So that's going to be x less than or equal to 2 gigs. Okay, and up here it was 21 years. Alright, just to make sure to put our units on there, right? So, on number 16, alright, let's get all that out of the way. Okay, it says to translate into an inequality. So a number x is greater than 8. So this is pretty easy to stake out. We got x is greater than 8. Whoa, done. I mean, like, this is going to take a whole new meaning to the word easy. Okay? Problems like this, you're going to pray for these to be on your test. Okay? A number y, okay, is at most 4. Okay, that means that 4 is bigger than y, okay? Or y can be 4, okay? Now, d is less than 23, okay? And r is at least -2. Okay, there's those words at least and at the most, okay? At the most is going to be that less than or equal to, okay? And you need to make sure that those are in their corresponding boxes at the beginning of this whole set of notes, okay? Those are going to be good for you to refer back to. So, the highest temperature ever recorded on Earth was 135.9 degrees Fahrenheit at Al-Azizia, Libya, on September 13th, 1922. Define a variable and write an inequality, okay? For things like this, I would want to use something like T for temperature, okay? So, it's asking about the highest temperature. So, in reference to everything else, it would mean that the temperature anywhere else on Earth has to be less than or equal to 135.9 degrees Fahrenheit. Okay? And that's pretty easy to figure out, right? Because temperatures aren't going to get any... We don't know that they might get higher, but for the time being, all temperatures on Earth have remained below that. Alright? Next, we've got Joy, who wants to save at least $40 for her trip to the amusement park. Write and graph an inequality to show the values of D that will allow Joy to meet her goal. So, $40, okay, and she wants to save at least $40. So, she'd be okay with $40, but she would prefer more. Alright? So, there is that. Okay? So, that's going to be X has to be greater than or equal to $40. Let's use, instead of using X, let's use D. D needs to be greater than or equal to $40. And voila! Notes are done.